Good morning everybody, welcome to the next lesson on beams. The question of course is to determine the support reactions. So that means we're going to have to determine the VA, which is going to be over there. And because there's only vertical reactions, because there's only vertical loads, there's only going to be vertical reactions. So there's not going to be an HA, but there will be a VA and there will be a VC. Okay, so we need to determine VA and VC. Right, notice the loads here. Notice that load, and that load. We call that, I didn't mention it in the first lesson, but we call those point loads. Point loads. Another name for point load is concentrated loads. Concentrated load. Same. Point load is a concentrated load. For example, a column in a structure, that's a point load or concentrated load. Okay, that's an example of a point load. That long one there, we call it a uniformly, I could have mentioned it before, but I'm mentioning more formally now, uniformly distributed. And of course, that's a long word, and we humans, we love acronyms because we're so lazy. We call that a UDL for short. Okay, so those are point loads, and there's a UDL. Right, let's take moments. Now, notice we are simply supported here with a cantilever there. Okay, I'm going to start at here. So I'm going to say the sum of the moments about A is equal to 0. Right, clockwise is plus, anti-clockwise is negative. Alright, notice if we take in moments here, all the loads on the beam will be positive. Doesn't matter the order, take any one. I'm going to do the point loads first. So it's plus 41 times 2.4. 41 times 2.4 plus 60 times 2.4 plus 1.8. That is 2.4 plus 1.8 is 4.20 plus 22 times 4.2 plus 1.2. So the full distance from the point of application to the point of rotation is 5.4 minus. Why minus? Because VC is anti-clockwise with respect to A, and VC is 4.2 meters away. Are there any more? Yes, you've got the UDL. Right. Now just put the brakes on you slightly. Kilonewtons. I'm sorry. Oh, forgot that over there. Naughty me. Kilonewtons there. Okay, kilonewtons. Hope you spotted that. Right, kilonewtons. That is kilonewtons per meter. That's a load or force. That's a load. That's a UDL. It's different things. Okay, right. Now a UDL, an example of a UDL could be a wall. Okay, meaning that every meter of it weighs 12 kilonewtons. Okay, but this UDL is 2.4 meters long. Okay, now remember when we take moments, that's the force, that's the distance. That's the force, it's the distance, force, distance, force, distance. The UDL, if I just said 12 times 2.4, that will not be correct. Okay, we need to work at the total load first due to the UDL. It weighs that much per meter and it is that long. So, for UDL, this is what we do. We say 12 times 2.4, how much it weighs per meter. We multiply it by how long it is, and that there is the force. And what's a moment? A moment is a force multiplied by a distance. Alright, and what's the lever arm for the UDL? Are you tuning in? The lever arm always acts through the center of the length of the load. Okay, I'll say that again. The lever arm for the UDL always acts through the center of the length of the load. So if that's 2.4 meters long, the distance from there to the point of rotation is 2.4 over 2. It is 1.2 meters. There we go. Times 1.2. There's no more. So it's equal to 0. Okay, is that sinking in? Let it sink in. So for the UDL, it's always the value of the UDL times the length times the distance from the center of the length of the load to the point of rotation. Now remember, this point of rotation is sitting over here, so it's just 2.4 over 2. If we were taking moments about D, you see where this is going to? It will be 1.2 plus 1.8 to wherever the point of rotation is. If it was there, it will be there. But if it was up to C, it will be 1.2 plus 1.8. Keep that in mind. Okay? Right, there's our first equation. We've taken moments about A, therefore, and we've got VC as an unknown in one equation, therefore we can determine VC. I'm going to pause this for a moment so I can keep the video short. I'm going to just pause this for a second. Let's get to work at. Right, people, and the answer I get there is 119.94. Please check me. Please check me. 119.94 kilonewtons. And because the answer is positive, it means that VC is acting upwards as we assumed. 1194. People, I'm going to check my answer again before I proceed. I'm going to check my answer again. Just give me a sec here. Okay, people, that's what I get. Alright. Notice once again, I'm taking moments about A to find VC. I'm now going to take moments about VC to find A. Let's do that. So I'm going to say the sum of the moments about C is equal to 0. Right. I'm going to start with VA, which is positive with respect to C. VA times, it's still 4.2. Plus, what's plus? I'm going to take that one there. Okay, notice here that that force and VA are acting in opposite directions, but they have the same moment effect about C. I'll say that again. Notice VA and 22 kilonewtons are acting in opposite directions, but they have the same moment effect about C. We call those two forces, we call it a couple. Okay, they're not going to marry each other. No, they're not going to do that. But structurally, it's called a couple. Okay, so that's why they both want to turn the beam positive about C. Or you could say we have a bit of a seesaw here about C. Okay, so it's plus 22 times 1.2. And it's going to be minus all the others. Now, before we say all the others, that force there, will that force have any moment effect about C? No, it won't. Why? Because any force going to the point of rotation has no moment effect. So I'm going to ignore that one and now only consider the 41 and the 12. I'm starting with the point load. So it's plus 41 times 1.8 minus 12 times 2.4. Remember, the value of the UDL times length, and that is the total value, the total force acting. We need to still multiply it by its lever arm. And its lever arm acts through the center of the length of the load. So from there to there is 1.2 plus 1.8, which is 3 meters. There we go. Right, let's see. So it is 1, 2, 3, 4. 1, 2. I'm just checking my forces. I think we've got everything in. It's equal to 0. We've got one equation with V as an unknown. Therefore, we can determine VA. Right, I'm going to pause here for a second so it doesn't go too long. Right, people, hope you got an answer. I got 31.85, 31.31.85. 0.85 kilonewtons. Put in the units. If we don't, I'll take over mark. And because the answer is positive, it means that VA, we assume to be upwards, is in fact upwards. So VA is 31.85 kilonewtons. I'm going to check by summing verticals. I'm going to say the sum of the forces in the vertical plane is equal to 0. So VA is 31.85 plus VC, which is 119.94, minus 41, minus 60, minus 22, and you can't say minus 12 for the UDL, because it weighs so much per meter and it's that long, so therefore it's minus 12 times 2.4. 12 times 2.4. Right, it should be not, but do the check. So it's 31.85 plus 119.94 minus 41 minus 60 minus 22 minus 12 times 2.4 is, I get minus 0.01. Why do I get a minus 0.01? Why do I get a small number? Because we've been rounding off the values here. So that for us is perfectly correct. So I'm going to say not. So that's correct. And that's correct. Okay. Once we start to get UDLs and we start rounding off along the way there, if we get an answer that's very, very close to 0, that's acceptable for us. Okay. It's very seldom exactly 0, but minus 0.01, that's fine for us. Okay, people. That's the end of the second lesson, and I shall see you in the next video.